this is simply, if I substitute 1, I will have 1 plus 5, and here I'll have 1 minus 5, which is just 6 minus 4. Right? So DFT of the sequence 1, 5 is just 6 minus 4. Okay, so what is DFT of the sequence 3, 7? Now, in what order the leaves appear? You had this for your assignment too, right? If you look carefully, these guys are precisely bit reversals of the original sequence, right? So DFT of 3, 7 is simply PEO of 3 PE, what am I doing? PEO of 1, PEO of minus 1, which is equal to 3 plus 7 times 1, 3 plus 7 times minus 1, which is just the sequence 10, and here is minus 4. Right? Okay, so now let's, if it don't make, I guess we can move here. Now we have to put things together. And the equations and, you know, the algorithm tell us how to do that. How do we do that? Well, if you look at the definition of PE, is simply y now goes through the corresponding roots of unity. So it's always the same story, you see. Y k is equal to yk of the even plus omega n k yk of odd if you range with k between 0 and k minus 1. So for k between 0, sorry, so so k, let me not mess it up, from 0 to n minus 1, right? But there is an easier way of doing it. Instead of doing that, you can also do this only between 0 and n over 2 minus 1, and have y n over 2 plus k equal to y k even minus omega n k y k odd. Right? Because omega, simply omega n over 2 plus k is just minus omega k. So let's now simply go through from the bottom up. So next sequence whose Fourier transform, we want discrete Fourier transform, we want to evaluate is which sequence? It's the sequence 1, 3, 5, 7. So now we have DFT of the sequence 1, 3, 5, 7, right, is equal to, we take whatever we have. What are the sequences? Let me know not to get them out of order. So P even is 1, 5, 3, 7. So that's this one. So it's 6 minus 4, and the other one is, let's see, 3, 7 is 10 minus 4. So we simply now have the first coordinate is 6, and I have to evaluate it first at 1, right? So 6, it will be 6 plus 10 times 1. So it's the sequence 6 plus 10 times 1, or I'll write it like this so that you see 1 times 10, because this is now omega 4 to the power 0, right? Then we will have something, and then we know that the next one will be 6 minus 1 times 10, and whatever we have here. Now we have to see what comes here. That's the second coordinate. So now we have, what is here? Let's denote this by 2. And this is 4, right? So what is 2? Well, this will be the second component of what we have, which is minus 4. So this is minus 4 plus omega 4 to the just power 1, right? Times the second coordinate here is minus 4, which comes to minus 4 minus 4i, right? And of course the 4 will be the same, but with the negative sign. So it will be 4 plus omega 3, 4 minus 4, which is of course minus 4 plus 4i, because you have this is minus i. Right? So the sequence that we get is minus 4, minus 4i, and here it's minus 4 plus 4i. Now we compute the DFT for the other polynomial.
Wait, Alex?
Yes?
What was the reason for that side that you were calculating minus 1 before minus 1?
If you always start with 1, so you always go in the order omega n 0, omega n 1, omega n 2, up to omega n to the n minus 1.
So in your, when you've got it expanded there, PE of 1.
Yes. So that's minus 1 to power 0, and this is minus 1 to power 1. Right, so this is, what is this? Let's write it down. So we have P E of minus 1 to power 0, P E at minus 1 to the power 1, because this is omega 2 to the power 0, and this is omega 2 to the power 1. Okay? Okay, so the second Fourier transform that we have to compute is the sequence 2, 4, 6, 8. So we now compute DFT of the sequence 2, 4, 6, 8. What is this? We have what are the values? The values are where? I think they are hiding here behind. So this is the odd one. So this, and where did I compute them? Yes? So you say it again? These two?
Yeah.
Okay, so this, look how we did it. It's always the same story. It is polynomial of half degree times the root, whatever it is, right? Times the value of the polynomial of half degree. So this exactly says, take the kth element of the sequence, which is the value of the first of the even part, plus whatever. So this is your y here, right? Whatever the root is, and then take the odd polynomial, the kth component of the odd polynomial, right? So now I have to see where I wrote.
We didn't do it again.
We didn't do it, eh?
No.
Oh, you're right, we didn't do it. Okay, so let's compute DFT. Let me try to squeeze it in here. So DFT of 2 plus 6z, so 2, 6 will be equal to, now you can tell me, compute in your head, what are the coordinates here? What is the DFT of 2, 6? First we substitute value 1, so this will be 2 plus 1 times 6, it will be 8. And then 2 plus 6 times minus 1, so it's minus 6 plus 2 is minus 4. Right? And then we have DFT of what do we have? 4, 8. What do we get? We get 12 and we get minus 4. Right? And so now I can calculate the value of this. I get first component here times plus 1 times this component. So it's 8 times 12, 8 plus 12. Plus. Now, root of unity of order 4. Right? So it will be omega 4 to the first power times what do we have now? So it will be 6 plus, wait a second. So it is 8 plus 12, that will be 20, and we have minus 4 plus I times this. So we have minus 4 plus omega 4 times minus 4. Right? Then we get exactly the same, but with minus 8, minus 12, minus 4, minus omega 4 times, so it will be minus omega 4 times minus 4. And what is this sequence? When you simplify it, this becomes 20 what is this? It's minus 4i, and then you have minus 4, and here you have minus 4 plus 4i. Right? Now, we can compute the final answer, right? What is the final answer? The final answer is just combining the two sequences, and you have to go through roots of unity of order 8 now. So let's just quickly. So now we can compute DFT of the whole sequence 1, 2, up to 8 is equal to the first component of the even part. What is the first component of the even part? It is, I cannot see it from here, it is 6, so it's 16 plus what is the, here is 20 plus 1 times 20, right? Then the next is, it is minus 4i plus omega 8 times what is the second value here? It's again minus 4i. Right? Then you will have, what is omega 8? We know what this is. This is square root 2 over 2 plus I times square root 2 over 2, right? And so simply, next thing will be the third component here. So let's see, 1, 2, third component is minus 4 plus omega 8 squared, right? And we know what this is. This is just omega 4 times the second component here. So, sorry, the third component here, 1, 2, 3, minus 4. And, comma, so the formula is always this, right? Kth component of the even part, omega n to the kth power, kth component of the odd part. Okay, so because we are out of time, I will post this complete solution on the web of this.